All right, so today is the culmination of all our matrix skills. We are going to solve systems using matrices. And we're going to just be solving these systems that are just two equations. Nothing more. Nothing too crazy. We'll be okay. All right, so I can set up a matrix and I can solve a system using matrices and inverses. Okay? So, bonus unit 1, matrices, solving systems. It's a thing. Matrices can be used to represent a system of equations written in standard form. Notice the ax plus by equals c, that's considered standard form. And we can solve them using a few methods. Before we talk about those, let's see what our goal is with our system of matrices. So we first can take, so notice that A ends up in its own column because it's representing x, B ends up in its own column because it's representing y, and C ends up in its own column because it's representing the number after the equal sign. Then the second one, same thing, M represents x, notice it ends up in the same column as A, N represents y, notice it's in the same column as B, and P represents the number after the equal sign. Notice that there are no x's or y's in this matrix. Please don't put x's and y's in that matrix. Just don't do it. Don't do it. So our goal is to end up with a 1 in the x column and a number after the equal sign. Notice that this will mean x equals this number. Then we'll end up with a 1 in the y column and a number here. And it just means y equals whatever that number is. That's all it means. It's super fancy stuff, as you can tell. All right, what does the first part of this matrix look like? We've got the 1, 0, 0, 1. Many of you should have come up with the answer. This looks like our identity matrix. And last time we learned how to take a matrix and multiply it by something and get something that's the identity. We learned about inverses. Hint, hint, we're probably talking about it today. Okay, there are two ways to solve matrices. To solve a system using matrices. One is called row operations. It's basically using the elimination method, but it's all doing all of the work in a matrix. And it's actually kind of cool, but I'm not going to make you do it. Because you guys overcomplicate it, and you already have a method that does the exact same thing. It's just elimination. That's it. You know how to do elimination. If you need a refresher, go back and look at it. But what we're going to be doing today is we're just going to be finding the inverse of the first part of the matrix. And then we're going to multiply by that matrix and solve. And it's going to beautifully give us our answer. And it's going to be wonderful. It will. I promise. Okay, so we're just focusing on the second one. All right, so this first one, we're going to set up the matrix first. So notice the 4 and 2 are in the same. Notice the x's are lined up, the y's are lined up, and the numbers are lined up. That's important. If they're not, they need to. So we've got 4, 2 in the x column, -2 and -1 in the y column, and 5 and -1 in the thing after the equal sign. Now I'm going to put that dashed line just to remind myself, hey, that means it's after the equal sign. It's important, I promise. All right, so now we want to find an inverse of this first part. So we're going to find the determinant. So I'm going to do 4 times -1, and then we'll subtract -2 times 2. So we've got 4 times -1. I'm already concerned about myself. So 4 times -1 is -4. And then -2 times 2, so I'm going to subtract. -2 times 2 is -4, and I get 0. Now what did we learn about 0? It means that there's going to be something special about this matrix. So in order to find the inverse, we'd have to do 1 over 0 times, we flip those two numbers, so we'd have -1 and 4. And we change the signs on these, so this would be +2 and -2. And we still have, and then that would be our inverse matrix for the first part. What happens when you divide by 0? You are correct. This ends up not existing, which means this system is a no solution system. Isn't that interesting? Ends up being no solution. It actually makes sense if you go through and solve it yourself, but that one's no solution. Let's see what happens when we have a solution. Should have put this one first. That's thinking for you. All right, so we're going to go ahead and make our matrix. So we've got 1 and 2 in the x column, -1 and 3 in the y column. I'm going to put this little dotted line to remind myself, hey, these numbers are after the equal sign. 2 and 8. Okay, This one better have a solution. Otherwise, you've got problems. All right, so first things first, find the inverse of the first part of the matrix. So we do 1 times 3, and that's 3. So 3. And then we're going to do minus, and then we've got negative 1 times 2. So we're doing minus negative 2. That equals 5. Beautiful. It exists. The inverse exists. All right, so now we've got 1 over 5. And we're going to multiply this matrix by its inverse. So we've got to flip these two. So we've got 3 and 1 flipped. So now it's 3 in this quarter and 1 in this quarter. Should I write this in red? I feel like I should write this in red. We're writing it in red. And then we've got to flip our signs on the other two numbers. So all of a sudden this is a positive 1 and this is a negative 2. Now, remember I always multiply 3 by 1/5 last just to save myself the heartache of multiplying by fractions, because that would make me sad. Okay, so first, I need you to notice something. This is a 2 by 2 matrix. This is a 2 by 3 matrix. So the 2's match so we can multiply them. So what's this going to end up being? A 2 by 3 matrix, which is exactly what we want, because we want that first part to be the identity matrix, the 1, 0, 0, 1, and then the last part should give me numbers. It should give me nice, pretty numbers at the end. It's going to be beautiful. Just wonderful. Flawless, even. Okay, so we're going to multiply our first row by our first column to get our first number. So we've got 3 times 1 is 3. And then we've got 1 times 2 is 2. 3 plus 2 is 5. Beautiful, because when we multiply 3 by that 1/5, don't forget this 1/5 is out here. Don't forget that, please. Okay, so then we're going to take our first row by our second column. And this is going to be negative 3 plus 3. This gives us a 0, which is looking good so far. All right, and we're going to take our first row times our first column. And we're going to get 3 times 2 is 6. Then 1 times 8 is 8. 6 plus 8 is 14. I had to double check the math there. I was very concerned about myself. All right. Then this second one, we're going to take the second row times all of our columns. So we're going to do negative 2 times 1 is negative 2. And then 1 times 2 is a positive 2. Negative 2 plus 2 is 0. Looking very promising. Okay, so then on this next column, we've got negative 2 times 1 is 2. Then 1 times 3. And that's going to be a positive 3, while 2 plus 3 is 5. Still looking promising. Feeling good about this. All right, and then we're going to multiply this last one by this last column. We've got negative 2 times 2 is a negative 4. And 8 times 1 is 8. Negative 4 plus 8 is 4. And remember, these are after the equal sign. Now, we need to multiply our 1/5 all the way through. So we do 1/5 times 5. And we get 1. 1/5 times 0, we get 0. 1/5 times 0, we get 0. 1/5 times 5, and we get 1. Remember, these numbers are after the equal sign. 1/5 times 14 is just 14/5. I know it's not a pretty number, it's okay. Then 1/5 times 4 is just 4/5. Now remember, this is my x column, this is my y column, and this is my answer column. So we end up with x equals 14/5, and we end up with y equals 4/5. So then our answer would be 14/5 and 4/5. Now I promise it goes a little bit quicker when you're not thinking it through, like doing each step and talking about it the whole time. All right, now I want you guys to go ahead and try. You can go rewatch that problem as many times as you need. Go ahead and try that one and that one, and then work together with different people. So this is a discussion board. You can scroll through other people's posts if it's already been class, or you can post your own discoveries. Write what the matrix would look like. So maybe take a picture of a matrix that you've drawn, that's this one, and see if you can figure out how many centerpieces should be on each table, and see if you can show that process using matrices to help you solve. No, you don't necessarily need matrices to help you solve here, which is why I created this problem the way I did. Once you've done as much work as you can on here, you will answer a short quiz that will have you answer how many centerpieces for each table there will be, how many on the round table, how many on the rectangular tables. Then go ahead and write your recap, and you are done for today.